Howdy, and welcome back to another episode of Bowmaths. In the last couple of videos, we've been looking at fraction multiplication, and we've explored several ways that we can use it or interpret it. And in particular today, I want to kind of continue that, but I want to review just a couple different ideas we've done first, and that's going to help us moving forward. So if you recall back to the video on symphonies and music, where we kind of use that video as like a worked application where we can use fraction multiplication in order to combine proportions. For example, if half the orchestra is trombone players, not a very realistic orchestra, but if half of the orchestra is trombone players, and let's say a third of the trombone players are over 33 years old, then what we could do is we could combine these proportions and say that a half times a third, or a sixth, of the orchestra is a trombone player that's over 33. Right? Because essentially we are looking at, okay, what piece of the orchestra is trombones? And we said, okay, half of that is. And then we're looking at what proportion of trombone players are over 33. So since half of the orchestra, that piece is the trombone players, then we're just focusing on that piece. We're focusing on the half, and we're taking the third of that piece, right? If you want some more context with that idea, please check out the video on symphonies and proportions. And then in the last video, we've talked about how fraction multiplication is really a double action. If I multiply 3 times 13 quarters, essentially what I'm doing is I am multiplying it by 13 and I'm dividing by 4. Right, so there were two actions associated with this fraction multiplication, a stretching by 13 and a division by 4. So now what I'm going to do today is we're going to kind of combine these ideas of proportions and kind of double actions of fractions. So let's consider a situation with a proportion. So suppose 9 out of 10 dentists recommend a given toothpaste. You always see this on commercials, right? It's always like, oh, our toothpaste is recommended by 9 out of 10 dentists, or this toothbrush is recommended by 9 out of 10 dentists. And then there's just that one dentist who hates absolutely everything. But suppose 9 out of 10 dentists recommend a toothpaste. So for the first part is, what's the proportion of dentists that recommend it? Well, it's written right there in the question, right? 9 recommend it, and the total is 10. So our proportion is 9 out of 10. That's not too hard, and that takes us right back to when we started doing fractions, where we kind of looked at one perspective on fractions was just having them as proportions. But now what I'm going to do is let's maybe think about 9/10 as an action. So this is using a perspective from the previous video. So 9/10 as an action is a stretch or a multiplication by 9, and it's a division or a compression by 10. Right? We saw that 9/10 is essentially where 1 lands after we've multiplied or stretched the number line by 9 and divided or compressed the number line by 10. Right? So 9/10 is where 1 lands after doing these actions. So that's why we can kind of think of this number as embodying what this action actually is. But one thing that we can also do is we can do this in the other order. It doesn't matter if we stretch first and then compress, or compress first and then stretch. We're ultimately going to get to the same result. So what we can do is we can also, on the flip side, think of this as division or compression by 10 first, and then stretching or multiplication by 9 second. It doesn't matter the order in which we do this, we're going to get the same result. Now, what I want to consider here is let's actually interpret 10 times 9/10 now. So use part A and B to interpret 10 times 9/10. Okay, so let's see what I mean by this. So what I'm going to do is we're going to consider, okay, 10 times 9/10. And if I use part B, essentially what I'm doing is I'm doing a compression by 10 or a division by 10, right? And then I'm stretching it by 9. So if I first consider, okay, division by 10, so that's applying the denominator's action. We get 10 divided by 10, which is 1, and then we have times 9, right? That's just the leftover piece. So then that's our stretch or our multiplication by 9, which gives us 9. So this isn't all that exciting, but essentially what we've done here is we've said, okay, we're doing 10. We're splitting it into 10 pieces. So each of those pieces is of size 1. And then we're taking 9 of those pieces, right? That's the double action of multiplying by 9/10. So in terms of part B, we took 10, split it into 10 pieces, and took 9 of those pieces. In terms of part A, what is 10 times 9/10 in the context of part A? Well, we're applying the proportion of dentists that recommend it, right? So we're taking 10 and we're multiplying it by 9/10. And essentially what that's doing is we're saying, okay, out of 10 dentists, if we apply this proportion to them, we get the 9. But that makes sense because 9 out of 10 dentists recommended this toothpaste, right? So it's as though that applying this proportion to the entire group there will tell us basically how many people follow what the proportion is saying, right? The proportion is saying how many people recommend toothpaste. We apply it to the size of 10 and we get 9 here. And essentially, these two ideas work really well with each other because applying the proportion to the 10 is essentially splitting the 10 up into 10. So basically splitting the 10 dentists up into these 10 individual dentists and then stretching it by the 9 or multiplying by the 9 is saying we're picking up 9 of these dentists that support it, right? So encoded inside of this multiplication by the proportion is a way to split up how many dentists we're working with and then count how many actually satisfy the property. That's the numerator aspect. So it's really cool how these two different ideas end up working together to accomplish this. And what's even cooler about this is we can do this for any number now. I can say, okay, if 9 out of 10 dentists recommended toothpaste, how many dentists would recommend it if we had 50 dentists? And we're still applying this proportion. So let's try that. How many dentists out of 50, so if you have 50 dentists, how many out of that 50 would recommend the toothpaste? So this is still supposing that the proportion applies to this group of dentists. Well, what we do is we take 9/10, we take our proportion, and we multiply it by 50. So if we do this multiplication here, we're going to get 9 times 50 over 10, right? This is just how we do fraction multiplication. 9 times 50 is 450. Divide that by 10. That basically just is going to remove this 0 here, right? Sliding the decimal over by 1, and we get 45. So 45 dentists would recommend that toothpaste. This proportion is basically saying what piece of these 50 recommend the toothpaste. And it's telling us how to find that piece. So first of all, we divide it by 10 to get 5. And then once we've done that, we multiply it by 9, right? Because the 9 is telling us how much to stretch it by. So inside of this proportion, kind of as we saw in part C, it's encoded into how we figure out the piece of 50 that gives us this 45. And what we can do afterwards is we can take these 45 dentists, put it out of this 50, and when we simplify this fraction, what we're going to get is we're going to get 9/10 again. So the amount of dentists here that recommended out of the total of 50 ends up representing the same proportion. And we can do this with bigger numbers as well. So now if I ask how many dentists out of 1,000 would recommend the toothpaste, we're basically going to do 9/10, right? Take our proportion and multiply it by 1,000. We're basically taking a piece of the 1,000. And specifically this 9/10 gives us the instructions of how to get that piece of the 1,000. We split up into 10 pieces and we take 9 of those pieces. And that's going to give us something that has this proportion that reflects the same size of piece. So if we multiply this, this is 9/10 times 1,000 over 1, which is going to be 9,000 over 10. And that will simplify to 900, right? 9,000 divided by 10 is 900. So that means 900 dentists out of this group of 1,000 would recommend the toothpaste. And once again, we can check. If we look at the 900 out of the 1,000, this can be simplified down into 9/10, right? These can both be divided by 100 each. So we get the original proportion that we had. So this is a cool application of fraction multiplication and of proportions, where we can use proportions. If we know some proportion of a group, we can look at different size groups, and all we have to do is just multiply by the proportion, and we can figure out how many people inside of that one group have the property that the proportion represents, right? So I hope this idea made sense to you, and I hope you found it interesting. It's kind of cool bringing all these different concepts together to really show why this is working. And as usual, in the next video, we're going to get some practice with this. I'll prepare those, so I hope you're looking forward to that. And again, never skip on the practice videos, because we always do more interesting and more difficult problems than what I show in the lecture video. The lecture video is just meant to give you an understanding of the idea, but the practice video, that's really where you're gonna get super comfortable with the idea. So I'm gonna see you there, but until then, you have a good one, you stay groovy, and I'll see you in that next video.